Hello and welcome everyone to the YouTube channel of Infinity Learn by Sri Chaitanya, and today we are gonna study one very important topic, that is impulse and impulsive forces under the chapter conservation of linear momentum. So which chapter we are studying? Conservation of linear momentum or conservation of momentum, right? In that particular chapter, today's lecture is devoted to the study of impulse and impulsive forces. Okay, my name is Ravindram and I have done my BTech from NIT Bhopal, and I have an experience of more than 8 years in teaching across in different institutes and organizations in India. Anyways, let's come to impulse now. First of all, what is impulse? Impulse is the effect of force over an interval of time, right? Now you will ask, sir, what is the effect of force over an interval of time? Technically, the effect of force is to change the velocity of an object. So technically, its effect is to change the overall momentum of the object in an interval of time. Anyways, so what is impulse? Impulse is the effect of force or impulse of a force acting on a body for a time interval. This is defined as this. Okay. Now, and in this particular case, if force is constant, suppose if force is constant, it will become integration of simply dt from t1 to t2, which will ultimately become f into delta t. When this will happen? This will happen if force is constant, and if the force acting on the body is not constant, then obviously we will have to integrate it like this. Anyways, so is it clear? Now what is the unit of impulse? You will say, sir, it's a vector quantity first of all, and its unit is Newton second, right? Its unit is Newton second. It is denoted by vector j. Okay, I hope this much is clear. Now there is another explanation for this thing, or another way in which we can understand this whole thing. It is, see, we all have already studied that effect of force is to change the momentum of the body or the system. Technically, we have already studied this thing. Yes or no? We have studied this thing. Now we will do a little bit of arrangement here, and we will say that dp vector is f dt. Can you see this? This thing is impulse. This thing, okay, f dt, this is impulse. Okay, so and if you integrate it completely from initial momentum to final momentum, so you will say, sir, delta p is equals to vector f dt integration from t1 to t2. That means this is impulse. So finally we can say that impulse is nothing but the change in momentum caused by the force acting on a body for an interval, right? So finally I can say that j, or impulse acting on the body, is delta p, which is equal to final momentum minus initial momentum of the body or the system. For this is also known as impulse momentum theorem. Do you understand? This is also known as impulse momentum theorem, in which impulse on a body or impulse on a body due to a force F is defined as the change in momentum of the body, right? Now you can ask, sir, how is it useful, where we will be using the concept of impulse and all these things. See, first of all, let's understand what is the use of this particular thing, okay? That is impulse. Let's try to understand. See, I will discuss on this point as well. First of all, let me discuss about this point. Integration means area under the curve, and since impulse is equal to f dt integration over an area from t1 to t2, I can say it is the area under the curve of f versus t graph. That means if you have a graph of force versus time like this, and you want to find out the impulse from an interval t1 to t2, so impulse will be the area under this graph Can you see that? Area under this graph in this time interval. What is this? This is delta t, right? So this is how we will say this is what? Area under graph, or this is also the impulse of the body. Do you understand? In this particular instant I am talking from T1 to T2. Is there any doubt? No, obviously there is no doubt. So I hope this point is clear. Now what I wanted to say is how we will be using the concept of impulse in different questions. So let's take example number 1. We will take 2-3 examples and we will try to understand how we are going to use it, okay, for the questions. So let's take this example number 1. It's a very simple question. Suppose there is a block given to you and the mass of the block is given 2 kg, right, and it is going with an initial velocity of 4 meter per second, and suppose a force F acts on the body and F is 20 Newton for 3 seconds. Okay, question is find final velocity of the object. Now you tell me how we will be doing this question. It's a very simple concept. You will say, sir, we can solve it easily. We can say force upon mass is what? Acceleration. Once we know the acceleration, we can say v equals to u plus at. U already is given to us, so we can simply find, as time is also given, acceleration we will find out, and easily we can find out what is the final velocity of the object, right? So you can do this. One method is very simple. You will say, sir, acceleration is f by m because force is constant. Simply we can write it like this. So it will be how much? 20 by 2 and it will become 10 meter per second square. Then finally you can say, sir, v final is equals to v initial plus at. No problem. V initial is how much? 4. Direction is same. A is how much? Because the direction of force and initial velocity is same, I can say the acceleration will also be in the same direction. That is why we can take both of them as positive. And acceleration quickly 10. And what is the time? 3 seconds. Okay. So 20 by 2, 10, 34 meters per second will be your answer. Okay. That means after 3 seconds this will be your velocity. Instead of using this concept, we can also use the impulse momentum theorem and can get the right answer. Now what is the impulse momentum theorem? We will say, sir, vector j is equals to pf minus pi. Now you say, what is final momentum? It is initial momentum plus impulse, right? Now what is impulse? If the force is constant, I told you impulse becomes f delta t, right? So final momentum is equals to initial momentum plus f delta t. Can we write it directly? Now what is initial momentum? You will say 2 into 4 plus, how much is the force acting? You will say, sir, 20 Newton. For how much time it is acting? You will say, sir, 3 seconds. So 4 2s are 8 plus 23s are, I suppose it is 23s are 60. So answer is 68. This is the final momentum, which is what? Mass is how much? Mass is 2 kg into final velocity, and again final velocity will be 34 meter per second. Can you see this? You can say, sir, it is very simple. Why are you even explaining these things? No, I understand your point. These are very simple. This is a very simple example, or I can say it is the simplest example, right? But why I am still telling you these things? Because you need to understand that this is also one of the method which we can use. Though this looks very simple to apply in this question, but in certain difficult questions, certain complex questions, you will find that this method is too much helpful for you. Otherwise, it will become very complex for you to solve some complex questions. So to solve complex questions, the solution will also become complex. Anyways, let's cut the crap and move ahead. So I hope this is understood. Here I have taken a case when the force was constant. Okay. Now let me take a case when the force is variable. Then let's see what happens. Okay. Suppose they tell you that F is equals to like 4t. Okay. And from t equals to 1 second to t equals to 2 seconds. Okay. Find force is acting for this interval. Find the final velocity if mass is 2 kg, okay, and initial velocity is 1 meter per second at t equals to 1 second. Okay. Now this is a very simple question. Now the force acting on the body is like this. I will draw it. It's very simple. This is the force acting on the body and this was its initial velocity. That means they both were in same direction, right? Now, if you are watching the recording, kindly stop the video and try to solve it. And if you are live, then solve it with me, right? So we will say, again we can apply impulse momentum equation, because here what is happening, force is being applied on the body over an interval of time, right? So we will say that here f dt, because since force is variable, can you all see that the force is variable, that is why we will say integration of f dt will be impulse. Okay, now what is this? You will say, sir, it is 4t dt from t equals to 1 second to t equals to 2 seconds. So I can say it is 4t square by 2 from 1 to 2, which will become 2t square from 1 to 2, which will become 2 outside, 2 square minus 1 square, which will become 2 to the 4 minus 1 is 3, 2 the 6. Okay, answer is 6 Newton second. Okay, so this is the impulse that you have got. Now you can simply say, sir, initial momentum plus impulse is equals to final momentum. Now what is the initial momentum? 2 into velocity is 1 plus impulse we have figured out to be 6. Final momentum is mass into velocity 2 into Vf. Now in this question you can say 2 plus 6 is 8 by 2 is equals to Vf, which is 4 meter per second. So from again this information we can easily get the value of final velocity. Can you see now again how useful it is? How much useful it is? With the help of impulse momentum theorem, we can solve the question so easily and get the answer. Right? Now there are other methods also. It can be even solved with work energy theorem also. If you have studied work power energy chapter, it can be solved with the help of work energy theorem as well. It can be solved with the help of normal kinematics also. You can say F is equals to ma, right? And then you can say A is what? dV by dt, and then from there also you can solve. Okay. So this is how we solve these kind of questions. Now the last variety, let me take it. I don't have enough space left, so where I will take it? I will take it here, the last variety, right? So try to understand. Suppose they have given that there is a graph of force versus time like this. Okay. Now this is the force, it is 20 Newton, right? And time is 4 seconds. This is t equals to 0. Again they have given mass of the body is 3 kg suppose, and initial velocity is 2 meter per second. Plus they have also given one information here is that the block is this and the force is acting here and the velocity is also here in this direction. Now what you have to figure out in this particular question, you have to find out the final velocity. Now in this question what we will do? Again we can apply impulse momentum theorem, and we can say that initial momentum plus impulse is equal to final momentum, right? Initial momentum plus impulse is equal to final momentum. Now what is initial momentum? You will say, sir, 3 into 2, right? Now what is impulse this time? Now we will use the third concept of impulse is what? First of all, what is impulse? F dt integration from t1 to t2. Second of all, what is impulse? Impulse is change in momentum, right? Impulse is change in momentum, or if force is constant then F into delta t, right? Then third is area under the force time graph, right? So here what you will do, sir, this area. What is the area of this triangle? Half into base into height. You will say, sir, it is half into base is how much? 4 into height is how much? 20 is equals to 3 into final velocity. Now you tell me how much is this? You will say, sir, 6 plus 40. 6 plus 40 is equals to 3 into Vf. I suppose from here final velocity will be 46 by 3. 46 by 3 meters per second. I suppose you get this answer right. So this is how we can solve it. Okay, this is how we can solve it. So students, are you understanding? If force is constant, we can say impulse is F delta t. If force is variable, we will say F delta t integration. And finally, if they have not given neither the value of force properly nor the relationship with time they have given, they might give you a graph. So in that particular case, you can see the area under the graph is also impulse. So till now what we have understood is what is impulse. Impulse is the effect of force over an interval of time, which is equal to F dt integration from t1 to t2, right. From other method we found out that impulse is also equal to the change in momentum. Okay, so if we can get the change in momentum of the body, we can get the impulse. Now last point I want to discuss is that what is the direction of impulse, right? What is the direction of impulse? Direction of impulse is simply the direction of the force, right? The force in the direction in which the force is acting on the body, in that direction only we will say that there is impulse, right? This is number one. Otherwise you can say impulse is also in the direction of change in momentum. Impulse is in the direction of change in momentum, that is also we can say. Okay students, now let's try to understand instantaneous impulse. Now what is this instantaneous impulse? Technically sometimes you must have seen that there's a problem. Sometimes what happens, the force acts on an object for an unknown amount of time and even the value of the force is unknown. That thing particularly sometimes happens. For example, suppose this is an object kept here right in my hand and I just bring it like this and it goes. Can you even tell me what is the amount of force that my right hand applied on the left hand and how much is the time of contact of my right hand with my fist of the left hand? Can you tell it? No. For another example I can take you, if I have a bat and you just bowl me, if you throw at me a ball, what will happen? I will just shoot it, okay, like this. So what will happen? The ball will come in contact with the bat. Can you tell me how much force does the bat apply on the ball? Or can you tell me for how much time, duration of contact, what was the duration of the contact of the ball with the bat? Is it easily found out? Can it be easily found out? No, it cannot be easily found out, but its impact can be found out. What is the impact? The impact is the momentum change that has been brought by the force that has been applied with the bat on the ball. Same line I have written here. There are many cases when a force acts for such a short time that the effect of force is instantaneous. Example, a bat striking a ball. In such cases, although the magnitude of the force and the time for which it acts may each be unknown, but the value of their product, that is the impulse, can be known by measuring the initial and final momentum. Perfect. Do you understand this thing? So it's so wonderful. So I can say here that we can use this concept, okay? Yes, fine. Right. So I will say that J is equals to vector F dt from T1 to T2. Now instantaneous impulse. So remember this thing very clearly. Let me take an example. Now instantaneous impulse. A simple example I will take. Suppose a ball is coming with an initial velocity of 4 meters per second towards a wall. Okay. Now let's say the mass of the ball is 1.5 kg and after colliding with the wall, this particular ball returns with the speed of 2 meters per second. Okay, same ball. Now we need to find out, in this example we need to find the impulse on the ball. ओके, वेरी सिंपल, फाइंड द इम्पल्स ऑन द बॉल। नाउ बॉल पे कितना इम्पल्स आया वो हमें कैलकुलेट करना पड़ेगा। अब कैसे करेंगे, यहाँ पे होगा क्या अल्टीमेटली, पहले वो समझने की हम थोड़ा सा यहाँ पे कोशिश करते हैं स्टूडेंट्स। जैसे कि जब ये बॉल वॉल के साथ कांटेक्ट में आएगी तो होगा क्या, ये बॉल जो है ये वॉल पे एक फोर्स लगाएगी F। अकॉर्डिंग टू न्यूटन्स थर्ड लॉ वॉल भी बॉल पे एक फोर्स लगा देगा -F इन द ऑपोजिट डायरेक्शन। टेक्निकली इट विल एक्सपीरियंस अ फोर्स F in this direction, and this force will be of very high magnitude because we all know that the collision doesn't take place like this. Does it take place like this? No. How does the collision takes place? You will say, sir, like this. The ball comes so fast and instantaneously its momentum changes. That means the force which was in contact with the wall was a very high force acting for a very short duration of time, such that it produces a substantial change in momentum of the ball. That means you can only believe you can like think yourself, the force was so high in magnitude that it reversed the velocity of the ball. The ball was going in this direction, it reversed its direction. Do you even understand how much of change in momentum it requires, right? So it requires a great change in momentum, and that is produced by a force acting for a very short duration. That means the force must be very high, right? So that is why we say that the force which is acting for a very short interval of time producing a substantial change in the momentum of the object is known as impulsive force, and it's very high in magnitude. Okay, now we can say find the impulse on the ball. A very simple concept. What we will do, we will say, okay, impulse momentum equation is equals to, sorry, this we will say plus J is equals to this, we know that. Now here the problem is J will become Pf minus Pi. Now we need to be very careful with the sign. Okay, what is the final momentum? Final momentum, you will say it is 1.5 into minus 2 minus 1.5 into 4. Can you see that? Now why I have taken minus 2 here? Because the velocity has reversed, right? So if I take this as direction, this direction as positive, so definitely I will have to take the opposite direction as negative. So finally I can say the impulse becomes, okay, it will be minus 1.5 into 2 plus 4, that is 6. 6 into 1.5 is how much? 9. So it will become minus 9 Newton. Now what is the, minus 9 Newton second. Now can you understand? That means this much amount of change in momentum has happened. Now what is the direction of the impulse? Now you tell me. Direction of impulse, I told you, is in the direction of change in momentum, right? Now what is the change in momentum here? It is coming out to be negative. That means direction of change in momentum is this, right? The change in momentum is in this direction. That is why we can say impulse is also, or the force acting on the ball also, both of them will also act in the same direction. क्या ये बात समझ आ रही है? Are you getting it? I hope yes. Okay. So sometimes it happens that the force which is acting on the body is very high in magnitude and we cannot figure out its magnitude, plus it is acting for a very short duration of time, that also we cannot figure out. But the overall effect of the force of high magnitude acting for a short duration of time, that is change in momentum, we can figure out, right? So that means the overall effect which is change in momentum, that we can figure out with the impulse momentum theorem. Are you understanding this thing? Okay, fantastic. So another example, let's take of instantaneous momentum, students. It's very simple, very easy. See, suppose there is a ball which is dropped from this height of, let's say, 80 meters, okay, and after colliding with the ground it goes back to a height of 45 meters. Are you understanding? So it is dropped from a height of 80 meters, collides with the ground and goes back to a height of 45 meters. So what you have to find out is find the impulse on the ball. ठीक है, सिंपल क्वेश्चन है और सिंपल तरीके से करना है. Now just we need to figure out how mass of the ball is given. I'll give it mass, take it as 2 kg. Okay, mass is given 2 kg. Now tell me what will happen when this ball collides with the ground like this. So the duration is very less. Can you figure out the duration? No. Can you figure out the force? No. Because the force which came at this particular moment is very high in magnitude, right? So very high in magnitude. That is why it's very difficult to find out the force and time separately, but the effect of force and time, that is impulse, that we can figure out in this question, right? Now are you getting the idea what I am trying to say, students? Right? Now what's going to happen here, let me try to explain you. When this ball was in contact, okay, with the ground, then the ground must have applied a normal force, okay, of very high magnitude, right? और ये नॉर्मल कैसा होगा? इंस्टेंटेनियस. मतलब कि ये बहुत कम समय के लिए आया होगा. इट मस्ट हैव केम फॉर अ वेरी स्मॉल ड्यूरेशन ऑफ टाइम and its magnitude must have been very large or very high. Do you understand? Now this particular force of very high magnitude changed the momentum of the ball to such an extent that the ball reversed its direction. Can you see with what velocity it was coming and with what velocity it reversed? That means great amount of momentum change, right? Now how we will figure out? Now you must be knowing this formula. What is initial velocity? You will say, sir, it is 2gh1 under root, and I will say it is minus. Why? When you throw an object, it comes down with the velocity what? Root 2gh. You know this? Yes or no? Now minus why? Because it is downwards. That's because downward direction I always take negative and upward direction I always take positive. So how much is that? Root 2gh1. That is initial velocity. Right, how much it is? Now let me tell you, minus 2 into 10 into 80. Can anybody tell me how much is that? Obviously you cannot say. So it is 1600 under root, that is minus 40 meters per second. That is your initial velocity. Now can you tell me what will be the final velocity? Again it is going to this height. So obviously we will say, if this is V final, this is V initial. So V final will also be how much? Root 2gh2. Okay. Now how much is this? 2 into 10 into what is h2? h2 is 45. I suppose it will be 900 root 30 meter per second. That too will be positive. Do you understand this thing? So we know initial velocity, we know final velocity. Just apply what? What we need to apply? Just apply the concept of impulse momentum theorem. Again we will say initial momentum plus j is equals to final momentum. What is initial momentum? Initial 2. What is velocity? 40 with a negative sign plus j is equals to 2 into 30 with a positive sign. So j will become 2 3 is a 60 plus, come on, 80. How much is this? 60 plus 80, 140 Newton second. So this is the impulse. And what is the direction of impulse? It is, since the answer is positive, that means impulse is in the upward direction. We can also represent this impulse like this. Students, just focus. N dt. Can you see that? Now what is this N? This N is the normal reaction acting on the ball from the ground. Okay, I hope you get this. Okay, so this is clear. This was a very good question. Okay, now students, one of the application of this is sometimes they ask you impulse. Okay, but sometimes they want to know what is the average force at least experienced by the body. Are you understanding? They want you to figure out what is the average force. Suppose they can say, okay, a force is acting on a body for some span of time, and in between the force became very high in magnitude and later on it receded, right? So there was a certain amount of interval we had. Now, so if the force was varying in that interval, so at least can I get an idea of an average force that must be applied on the body? Are you understanding? So sometimes impulse momentum, with the help of impulse momentum theorem or the value of final impulse that we get, we can also find out the average force acting on the body, right? I'll tell you how. Suppose there is a body on which a force is acting like this. Why do you go here? Come that side. Suppose a force is acting on a body like this. It growed enormously in between and then fell back, and then fall back, okay, and then fell back. Got my English. Okay, and then fell back. Then what happens here? Can you see? And this is not an accurate graph because I also don't know what happened. See, I can say suppose you throw a ball at me and I struck the ball with the help of a bat. What happened? For some small amount of time, the ball was in contact with the bat, and what happened? The impulsive force of the bat changed the momentum of the ball, right? During that interval, when the ball struck the bat and returned back, in that interval, what happened? The force that was acting grew to a very large value and then receded back, right? Now that is this. Now what do you want? Since the force is varying, we don't want this. We said on an average, if I took 3 seconds to take that shot, sorry, not 3. Suppose if I say I took 1 second or 1.5 seconds to take that shot, in that particular shot, how much force did the bat or in return my arms experienced because of that stroke? Okay, what happened? Let's say, so we will say the force grew like this. Okay, the force was not a constant one, it was very much impulsive in nature, because of which its value grew from a small to a large one and then came back, right? And this is the change in momentum, right? This is delta P, or we can also call this is impulse, right? Now, but what I want is I want something else. This time I want what is the average force experienced by the bat during that duration. So you will say, see, the change in momentum is the consequence, or impulse is the consequence, right? So what we will say, let's keep the consequence same. And say, instead of this variable force, if some constant force would have acted, then in how much and for a time delta t, then how much force that should that be, so that it can produce the same amount of change in momentum, right? Again I will say, instead of this variable force, if a constant force was to act on the body, how much should be the magnitude of that force, so that in an interval of delta t it would have produced the same amount of change in momentum. ठीक है, फिर से बोलता हूँ हिंदी में एक बार और, जब मैं ये बोलना चाह रहा हूं कि अगर एवरेज फोर्स निकालना है तो बात ये हो रही है कि कितना फोर्स लगाया जाए कांस्टेंट वैल्यू का, ताकि वो एक इंटरवल डेल्टा टी में उतना ही चेंज इन मोमेंटम प्रोड्यूस कर दे जितना ये वेरिएबल फोर्स प्रोड्यूस कर रहा है एक इंटरवल में, राइट. So we will say, let's say that force comes out to be this. This is that constant force. We will call it as average force, right? it was acting for time t. Now what is the area? Again we will say the area is this, and this time I am going to say that again same area, same change in momentum, same impulse. Okay, so areas are same, that means impulse due to both the forces are same. So can I say like this, can I say, and surely I can say that F average into delta t is equals to integration of f dt. Do you understand? So can I say like this, from t1 to t2, so can I say that F average will be equal to or I can say impulse upon time interval. Do you understand this thing? I hope it's a very simple concept, very simple and easily understood. So this is how we figure out sometimes the value of the average force acting on the body. Got it everyone? Okay. So this is sometimes very helpful. Now related to this concept only we have this question. This is a very good question, very famous question. Let's take this question quickly. Okay. Now what does this question say? It is saying the hero of a stunt film fires 50-gram bullets. Okay, so the weight of each bullet is 50 grams from a machine gun. Okay, machine gun means a gun which fires bullets constantly in one round, right? Each at a speed of 1 kilometer per second. Okay, the speed of one single bullet is given. If he fires 20 bullets in 4 seconds, right? So how many bullets he is firing? 20. In how much time? In 4 seconds. What average force does he exert during the machine? Okay, okay. First of all, what information we have? We have number of bullets fired in an interval is how much? 20 bullets in 4. That means 5 bullets per second on an average is being fired. Do you understand? Now, what is the change in momentum of every bullet? You will say the change in momentum of the bullet, which of a single bullet I am speaking, right? Of a single bullet will be how much? It will be 50 grams. We need to convert it into kg. Into change in velocity will be v minus 0, right? So it will be 5 by 100 into what is the speed that it is? 1 kilometer per second, right? Like this. So this is gone. Answer will be how much? 50 kg meter per second. Now this is the change in momentum of the single bullet. These many bullets are being fired. Now what they are asking is average. What they are asking is how much? What they are asking? Simply tell me. They are asking the average force acting on the body, right? Now average force, because see, if I talk about instantaneous force, it will be very high, right? Because for every bullet like this, like single bullet, like this, okay, 1 bullet, 2 bullet, 3 bullet, 4 bullet, 5 bullet, 6 bullet, 7 bullets, like this. So what is happening? Every time a bullet is popping up, it is being. So this is happening like how many times? 20 times in 4 seconds. In 4 seconds, 20 bullets are being fired. So obviously the instantaneous value of the force, if I want to figure out, that will be very, very, very high, right? But I cannot do that. So what I am going to do is, I have taken a certain amount of interval of 4 seconds. In that 4 seconds, what is the average? What is the average force the gun is experiencing, or at last my shoulder is experiencing, right? Because I'll be, or the person in the, or the hero in this particular question will be holding the gun against his shoulder, okay? So obviously what average force does he exert against the machine gun? Does he exert, or does the machine gun at last exert on him? Same thing, right? Now how we will figure out the average force? What is the average formula for average force? Impulse upon time interval, right? Impulse upon time interval. Now very good, very good. What is impulse? Impulse on a single bullet is this. So F average will be this upon time interval, but this is for a single bullet and time interval is given for 20 bullets. So we will say it should be multiplied by total number of bullets fired in this interval, right? Because this is the impulse of a single bullet, multiplied by total number of bullets fired in this interval. We will get the average value of the force. So this is how we will say it is how much? 50 into n by delta t is what? 5. On an average, his body is experiencing 250 Newton of force, or he applied a force of 250 Newton on the gun. Do you understand this thing, students? Come on, let me know. Clear? I hope it is. I hope it is clear. Okay. So that's all for today, students. Okay, nice. So we have understood what is impulse and what are impulsive forces. What are impulsive forces? These are the forces which act on a body for a very short duration of time. Okay, and create a substantial amount of change in momentum. Right? Okay. Thank you, students. Please subscribe to our channel and keep learning infinitely. Okay. Thank you.